Okay. What's happening on the left and right side of our graph? Both sides is doing what? Going up. Good. So what are we going to write? Both sides have positive infinity in behavior. Good job. This is the left. This is the right. They're both going up. On this graph, though, this is the left. This is the right. What is the graph doing on the left? Down. It's going down, okay? Because it's going down or decreasing, see how it's decreasing? It's negative infinity on the left. On the right side is going up, so that would be what? Positive infinity. All right, any questions about our bell work? Go ahead, take out your note packet, and we're going to practice sketching graphs using some of the characteristics that we learned in this unit. We're going to sketch. And we're really going to only focus in on 2 characteristics to help us sketch our graph, to make it simple. Can somebody tell me what page number this is, just so I'll know? 10? All right, so let's go to page 10 in our notes. So I'm focusing on intercepts, and I'm really focusing on intercepts and in behavior. Some of the other things could be a little bit, they're all helpful, but those are the 2 things that will help us the most. Intercepts and in behavior. That's going to help us sketch our graphs. All right, so let's go ahead and look at this first one. It says sketch a linear function. So because it tells us that it's linear, I know that it's going to be a straight line. It's kind of like playing the game of Clue. We have to use these clues to figure out what is the graph going to look like. Thank you. All right, so we're going to use these clues to create our graph. So it told us our y-intercept, where is our y-intercept? Where did it say our y-intercept was located? -70. Go ahead and plot that point. Put a point at -70. So that would be right here. Now it also gave us another clue. It says that for values of x greater than -30. So this tells us that I have an x-intercept at -30. Let's go ahead and put a point there. And then using that, go ahead and make your graph. It should be a straight line. Okay, it's kind of hard for me to make my straight line here because I can't use a ruler, but that's pretty much as straight as I can get it. And that's it. So we just used our graph to show what is the graph going to do. Now let's go ahead and talk about this in behavior statement. Thank you, Stacy. I'm sorry, you just the getter-upper for today. You can just put it on my desk. Okay, so right here, this is the right side. This means that the right arrow is going to go down, and this is telling us that the left arrow should go up. Does our graph do that? Does our graph go up on the left and down on the right? All right, so we know we sketched it correct. And that is what our graph should look like. Okay. Now let's do another one. Now let's talk about a nonlinear. So now we have, now let's talk about a graph that's not a straight line. So this one is not a straight line. Let's go ahead and plot what we know. We know that it has a y-intercept at +3. So that'll be about right here in between 2 and 4. We know that it's not going to be a straight line. It's continuous, so it has no breaks. All of the x values are positive. It has the lowest point is at 0.3, but the main thing here is our end behavior. So here is telling us that on the right, the arrow goes up, and on the left, the arrow goes up. So we have to make a graph. It goes through that one point, and both sides go up. So we sketched a graph that looks like it meets all of the criteria in that scenario. All right, next graph. Let's look at example. Example 3, and then we'll end there. So it says, Hay is test driving a car that she is thinking of buying. She decides to accelerate to 60 miles per hour and then decelerates to a stop to test its acceleration and brakes. It takes her 15 seconds to reach her maximum speed and an additional 15 seconds to come to a stop. Use the key features to sketch a graph that shows the speed y as a function of time. So her y-intercept, she started off at 0. So let's go ahead and start and put a point here at 0. This function is nonlinear. Her maximum speed is 60 after 15 seconds. So at 15, we're going to put a point at 60. So 15, we're going to go up to 60. Let's put a point right here. So in the beginning, she's increasing at a uniform speed. So go ahead and connect these 2 points with a straight line. And then Hay decreases the speed at a constant rate. Until she reaches 0 miles per hour. And she's going to do that for an additional 15 seconds. So that means 15 plus 15 is 30. So when she hits 30, she's going to hit 0 again. So we're going to connect that. So because she started at 0 miles per hour and ends at 0 miles per hour, there is no end behavior. So this graph has no arrows. This graph it does not continue. She cannot go any less than 0 miles per hour. All right, I'm going to pass out homework 3. Homework 3 is due on Monday.